everyone! In today's video, we're diving into an exciting discovery that might just unlock one of the universe's darkest secrets. For nearly a century, dark matter has been a go-to hypothesis to explain many of the mysteries of the cosmos. Ever since Dutch astronomer Jan Oort first suggested it in 1932 to explain the missing mass necessary for galaxies to clump together, dark matter has remained a key yet elusive concept in astrophysics. But despite all the theories and research, we've never found direct evidence of this mysterious matter. But what if we don't need dark matter at all? Dr. Richard Lieu from the University of Alabama in Huntsville has introduced a groundbreaking theory that could change everything. His new research, published in the monthly notices of the Royal Astronomical Society, suggests that gravity can exist without mass, potentially eliminating the need for dark matter altogether. Dr. Lieu explains, "My inspiration came from searching for another solution to the gravitational field equations of general relativity. The simplified version of these equations, known as the Poisson equation, shows that you can have a finite gravitational force even without any detectable mass." His frustration with the status quo and the lack of direct evidence for dark matter drove him to seek alternative explanations. Dr. Lieu proposes that the extra gravity needed to hold galaxies and clusters together might come from topological defects formed during the early universe's phase transitions. These defects, which are structures commonly found throughout the cosmos, could have been created when the universe underwent a major change in its state of matter. These topological defects can take the form of cosmic strings, which are linear structures or spherical shells. According to Lieu, these shells consist of an inner layer with positive mass and an outer layer with negative mass. Although the total mass of both layers is zero, a star on this shell experiences a strong gravitational pull toward the center of the shell. Dr. Lieu further explains that gravitational force fundamentally involves the warping of spacetime, allowing all objects to interact with each other regardless of their mass. For instance, massless photons experience gravitational effects from astronomical objects, which has been confirmed through observations. Lieu's theory also suggests that the bending of light by these concentric shells can mimic the presence of dark matter. The bending of light by concentric shells mimics the presence of a large amount of dark matter in much the same way as the velocities of stellar orbits do, he notes. This means that both the deflection of light and the orbital velocities of stars are the only ways to measure the gravitational field strength in a galaxy or cluster. If these shells are indeed massless, as Lieu contends, then we might not need to continue the seemingly endless search for dark matter. Looking forward, researchers will need to explore how these shells align to form galaxies or clusters and understand the evolution of these structures. Dr. Lieu acknowledges, this paper does not attempt to tackle the problem of structure formation. A contentious point is whether the shells were initially planes or even straight strings, but angular momentum winds them up. There is also the question of how to confirm or refute the proposed shells through dedicated observations. Despite the challenges ahead, Dr. Lieu's work offers a compelling new perspective on gravity and mass. He concludes, even if it's just a suggestive mathematical exercise, this is the first proof that gravity can exist without mass.